Got 6 people up for promotion. They've all worked at the company less than 3 years, but we are dividing them up into whether they've worked there 1 year or otherwise. They're only, of those 6, going to promote 3 of them. Now, apparently, they're doing some rounding. Exactly 1 year or exactly 2 years, not 3, because it does say less than 3. That's strictly less than 3. And of course, someone working there 0 years would have just started. They wouldn't be up for promotion yet. So, what is the probability of the 3 promoted that exactly one of them has worked for the company for 2 years? I've named already the event that we're finding the probability of. Note that when you select someone for promotion or leave them out, either way, there's no arrangement and no repetition. Now, they may have ranked them at first, but once we've got those that are going to be promoted, they're being equally promoted. So we're dealing with combinations. First of all, we should calculate the size of the sample space using combinations. And there are 6 available. Choose 3 of them to be promoted. That's without the condition that we're talking about in E. Then we would find the size of the numerator, most likely in the same way, but add in that condition. Exactly one of them has worked there for 2 years. Now, of those 6, we know that 4 have worked there for only 1 year. That leaves us 2 of them that have worked there for 2 years. We need to select both from the ones that have worked there 2 years, just one of them. And so an application of the multiplication principle, we've got one overall task to select the exactly one that has worked there for 2 years and gets promoted. But then since we had to promote a total of 3, the other 2 must come from the 4 that have only worked there for 1 year. And you can check this on your calculator. The 6C3 that I have above, 2C1 and 4C2 that I'm saying are 2 and 6. Multiply together in the numerator, we've got 12 over 20. Divide top and bottom both by 4 to reduce that fraction and get 3/5. As for the second part, we're going to look at this 2 ways. The first way is to reword the event being described there. At least one has worked for the company for 2 years. If I have a discrete random variable that counts the number that have worked there for however many years, well, it's less than 2, sorry, less than 3. So there's going to be either that it's 1 or 2. Then looking at the probability, at least one has worked there for 2 years. That is the complement of working there less than 1 year. So let's see here. Oh, I'm sorry. At least one has worked there for 2 years. So we could have either, since there are only 2, 4 of them worked there 1 year. 6 minus 4 is 2. So you could have none of them, of the 3 being promoted, none of them may have worked there for the 2 years. They may all be working there just the 1 year. Or you could have 1 that worked there for 2 years and the other 2 are 1 year. That's what we had up here. Or we could have 2 out of the 3 work there for 2 years and the remaining 1 only 1 year. The complement of that is that none of them, at least one, covers these 2 right here. Complementary event is that none of them that get promoted have worked there for 2 years. They'd all have to come from the pool that worked there 1 year. So we select none of, from the 2 that worked there 2 years, select none of them, and select all of them all three of them from the four that worked there just 1 year. Same style of computation using combinations, still no repetition, no arrangements, and it's still over the 20. So what we get there is as follows. Check this on your calculator. As a reduced fraction, I'm getting 4/5. However, since we had already answered part one, we already knew this probability. Then what we could have done would have been to say, well, at least one has worked there for 2 years. Would mean either one or two have worked there for 2 years. These are mutually exclusive events because for that one batch of promotion, you're not going to have both exactly one out of the three being there for 2 years, and at the same time, exactly two of the three that get promoted having worked there for 2 years. So because they're mutually exclusive, no double counting to worry about. We can just take our previous answer and add to it this probability. Again, we'll have a similar approach to computation there. From the two that have worked there 2 years, pick both of them. And since we had to promote a total of 3, notice the R values here, 2 and 1, add up to 3. The N values add up to the 6, the total that we're promoting. That's why I did this back here, even though 2C0 is 1. Again, you could check this on the calculator. The 2C2 is 1, 4C1 is 4. So I'm getting 3/5 plus 4/20. That reduces, add 3/5 plus 1/5 to get the same answer I had up here of 4/5.